Question 11 is all about factor theorem and finding stationary points and points of inflection and that sort of thing on a polynomial. So if you have a look at the question here, we are given a polynomial, but we don't know the values of a and b, so those constants there. But we are told that 2x plus 1 is a factor and that it has a point of inflection at x equals 1/6. So let's take the first of those clues. G of x, we are told that 2x plus 1 is a factor, and that means that if you do g of minus a half, it should equal 0. Remember, if this is a factor, then when 2x equals minus 1, you will get a 0, and therefore x equals minus a half gives you a 0. How am I going to use this? Well, I'm going to substitute minus a half into here, and it will give me hopefully an equation with a and b in it. So let's do that. 4 lots of minus a half cubed plus a so that is minus 4/8. This is a quarter of a. That's minus 2. And if I sort of simplify this a little bit, what's that? Minus a half. So it's 1/4 a plus b equals, what's that? Minus a half and minus 2. So minus 2.5. So 2.5 on that side. Okay, that's the first piece of information that we're given, that 2x plus 1 is a factor. So we've got a reasonable sort of conclusion from that. What I'm hoping is that using the second piece of information, I'll be able to make a second equation, and then I'll be able to solve them as simultaneous equations. So let's have a look at that second piece of information. We're told that there is a point of inflection at x equals 1/6. Now, be very careful with points of inflection. A point of inflection isn't necessarily a turning point or a stationary point. So you can see here in this diagram, look, there we go, point of inflection, and I've tried to make it so that it's got a gradient of 0 at that point. But you can also get points of inflection which go like this, where the gradient at the point of inflection is not 0, so it doesn't count as a stationary point. But it does have that change in the curve from concave to convex, or the other way around. So if you're looking for somewhere that has a point of inflection, you're not necessarily looking for dy by dx to equal 0. What you are looking for is the second derivative to be 0. Remember that what that means is if your second derivative is negative, then you've got a continually curving downwards graph. Curving downwards, so you get a maximum point. If your second derivative is positive, then you get a curving upwards graph, find a minimum. But for a point of inflection, the second derivative equals 0. Okay, so that's the information I'm going to use. The second derivative, so g dashed x and then g double dashed x, that's one I need, and that one is going to equal 0. So the derivative of g of x, I can't put g of x back on here, but let's just do it. 12x squared plus 2ax plus 4, and then take the second derivative, so 24x plus 2a, and this is what I'm saying has to equal 0. We are also told that this occurs when x equals 6. So look at, there we go, we're told that there's a point of inflection when x equals, misspoke there, not 6, 1/6. So the x stands for 1/6. And you can see we're quite quickly getting A equals minus a half. What am I talking about? It's not minus a half at all. Sorry, I was just checking the answers. Minus 4 divided by 2. Wally. Minus 2. So once we've found the value of A, it's fairly simple to go back to that information there and to find the value of B. So let me just summarize those two bits of information. We've just found that A is minus 2. We knew from earlier that a quarter A plus B equals 2.5. Since A is minus 2, that is minus a half plus B equals 2.5. So B is equal to 3, which is correct. So the answer to that part A was minus 2 and 3, all correct. Part B of this question says, show that there are no stationary points on the curve y equals g of x. So if there are no stationary points, that means that g dashed of x equals 0 has no solutions. So if we try to do g dashed of x equals 0, then we should be able to sort of show that it can't be solved. So that was 12x squared plus 2ax plus 4 equals 0. Or remember, we know the value of a now, so I'll just rewrite that. And now I can see, oh, this is going to be quite simple because I can divide everything by 4. And maybe use, if there are no solutions, remember, if I check the discriminant of this quadratic, let's work out what that is. So b squared, so that's 1 minus 4 times 3 times minus 1. Have I done something wrong here? Oh, I changed that to a, look at that. There we go. Okay. Don't quite know why I changed that 4 to a minus 4. B squared minus 4ac here, look, is 1 minus 4 times 3 times 1. So that is 1 minus 12, which is minus 11. And therefore, since b squared minus 4ac is less than 0, there are no real solutions.